Hi guys. Alright, we're continuing on math. Trigonometric functions of trigonometry. It's basically math of triangles and circles, but it's also the math that basically is necessary to fully understand a sine wave, which is your base wave for radio. So we'll get started on it. First thing you have, there's two ways of looking at it and teaching it and dealing with it. The standard pure math way is to use a circle. And it's called a unity circle, which means that at each point that it crosses here will be 1. The radius is 1. So unity. That's one way of looking at it, and we'll discuss it a little bit here in a little bit. The more simpler way to understand it is with a triangle. Now H stands for hypotenuse. You've seen probably in basic algebra or basic math a right triangle, and that's what this is. It's a 90-degree angle here, and you got the hypotenuse. These two sides, one is adjacent side, meaning it's adjacent or next to our angle of interest. The other side is the opposite or opposite of the angle. Little angle here is a circle with a line through it, just is a Greek letter theta. Angles can be generally labeled anything. They can be theta, alpha, beta. Yeah, you can also label them T, R, whatever. In this case, I'll just use theta. There are three base functions. One is sine, the other one's cosine, and then tangent. Now there's others that are not used as much, and that is secant, which is 1 over cosine, cosecant 1 over sine, and cotangent 1 over tangent. These you don't generally see a lot. It's really the primary, the first three, and generally they're shortened in a form such as this. Just leave off the e's and leave off most of the tangent. That's the way you normally would see them. But sine theta, the sine of this angle, is a ratio or a division problem of opposite over hypotenuse. So this side divided by this side, take the sine of that, or sine of theta, that's what that equals. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now the way, one quick way you can remember those is a little saying, a little sentence. Oscar has a heap of apples. So Oscar has a heap of apples. So that's one quick way of remembering them. Now this opposite over adjacent tangent brings us to, there's things called trigonometric identities. Brings us to the first one. Tangent is also nothing more than sine over cosine. So that's one identity. There are actually several identities. I believe it's 275 or something like that, trigonometric identities, but there's only really two that serve any real interest. Now when we look at the circle, come back here, we have a coordinate system. You have X is your horizontal, Y vertical. Cosine is X. So cosine of the angle gives us the X coordinates. Y equals sine of theta. So sine of this angle theta gives us the Y coordinate. The two combined will give us a point anywhere along here, wherever this, along the circle, depending on the angle. That brings us to a second identity, and that is sine squared theta plus cosine squared theta equals 1. And what that really is saying, that if I go back to the circle, since this is a unity circle, in other words, the radius of the circle is 1, sine squared plus cosine squared gives me 1, which is also the same thing as saying then, by just using this and substituting in, that x squared plus y squared equals 1. Now, why unity circle? Well, the reason for just what they call a unity circle, or just a circle with a radius of 1, is it's not that trig only works with something to that size, or a hypotenuse, which is what the radius actually is the hypotenuse of a triangle. It's not that it can't work on anything else, but any longer sizes or anything, you can, but they're just multiples of 1, multiples of x, multiples of y. So that's how they work out. This is actually the same thing as you've probably seen the right triangle having different labels, like A, B, and C, and then they're saying A squared plus B squared equals C squared. Well, that's actually the same thing as this. If you put that on a coordinate system, x, y, then A, x, B is y, and C will be the 1, or h, or hypotenuse. That's your simple solving of a right triangle. And that's all this is doing. Now, what trig is useful for, or anything else, it's used in a lot of areas. You can use it for finding the height of something from just its shadow. If you wanted to find the height of something, you can use it for navigation. It's considerably used tremendously for navigation, because then you can draw out, figure an angle, draw out the hypotenuse, and find where your coordinates are and where you're going and stuff. And basically a lot of the stuff that you do, you make use of the ratios, but you can find like the opposite side by just rearranging the formula and going h sine theta equals the opposite side, and doing something like that. If you know this and you got the angle, you can find this by just doing that, by just simply rearranging the formula. You can also rearrange it where if you know this, you can find this. So however you rearrange it, you can find one of the two sides. They're marked on your calculator. If you got a scientific calculator or something of this nature, you have sine, cosine, and tangent. Above those, and I don't know if you could see that, above those is sine minus 1, cosine minus 1, tangent minus 1. Now what those are is inverses. And the proper name is arc sine, arc cosine, arc tangent. And what you do with those, if you already know your ratio, say I knew this and I know this, I can do the ratio, do the division out, and then I can plug that in the calculator and use arc sine to find the angle. It'll give me the angle. That's probably about as much as I'm going to do on this right now. In a part 2, we're going to kind of talk a little more about the circle and stuff, and we're also going to then take it into where it comes in for a sine wave on, say, oscilloscope. Where does this fit in to radio and electronics and stuff? So in part 2 we'll do that and go over this. This is enough to give you something to bite on. Again, Oscar has a heap of apples. Sine, cosine, tangent. As long as you remember that, you can remember the ratios and remember what they stand for. So until next time, thanks for watching, and thank you for your comments and stuff. I'm still working on trying to answer comments from way back, so I'll get to them. But yeah, thanks again. See you on the next video.